All right, so going over the practice exam that I posted last Sunday, I believe. So yeah, I'm just gonna go through it. So the first one, we have to name this molecule. So we have its structure. So our first step is always to figure out what kind of molecule we have. We have an alkane because there's all single bonds, which means we're ending in ane. All right, this happens to be a ring though. So we're going to have to put cyclo before our parent chain, but we're not quite there yet. The ring is always the parent chain, all right? So I'm going to highlight this in yellow. Since it's an alkane, there's nothing really to highlight in blue because alkane is basically the absence of a functional group. My next step is to number this. So with rings, you want to put one at the branch. So here I'm going to put one at this branch, and it wouldn't have mattered if I chose this one, but I need to start at one of the branches, and then I need to make the other branch number 2. All right, and I'm gonna go 3, 4, 5, 6. All right, so I'm gonna start putting pen to paper. It's an alkane, so it's gonna end in ane. There's 6 carbons in the main chain, so hex. There's it's a ring, so we're going to throw cyclo. All right. And so if it was only what's highlighted, this is where we'd end. But we do have 2 branches here. So they are 2 carbon branch. All right. 2 continuous carbons. They look like an elbow, so they're both ethyl branches. So we're looking at 1, 2 diethyl cyclohexane. All right. Number 2 is very hairy. All right, the hardest, it's still an alkane. We're still in that alkane functional group, all single bonds. The hardest part here is figuring out that longest chain and kind of where those branches fall. So I will have to count here. So I think it is this. 1, 2, 3, 4, 5, 6, 7. Versus this would be 6 if we went straight across. This would be 5, 6. Yes, so I believe it's 7. All right. So just to figure out where the main chain was, I numbered it, but I'm not sure. Yes, we will want to number it left to right because we want to put these branches at the lowest possible position, right? So we have a branch here at 2, 3, 4, and 5 versus if I went the other way, it would have been 3, 4, 5, 6. So this is right. All right. So ane, because it's all single bonds. Hept, because there's 7 in the main chain. And now we got to deal with all these branches. Crazy, crazy branches. All right. So this is a 1 carbon branch, methyl. 3 is also a 1 carbon branch, methyl. 4, 2 carbon branch, ethyl. 5, 1 carbon branch, another methyl. So we got 3 methyls and an ethyl. Okay. Now, when we have 2 like different functional groups, we list it alphabetically. So we're going to start with this 4-ethyl. So 4-ethyl. And then we're going to do the methyls. And so we haven't seen this example yet, but this is a trimethyl. Maybe you've seen it in your owls or something, but instead of two, we have 3 tri. So I got to list all these numbers. 2, 3, 5, trimethyl heptane. So 4-ethyl 2,3,5 trimethyl heptane. All right, any questions? All right, I'm going to keep chugging along. All right. So here we need to figure out which molecule has the highest boiling point. So we would refer to our trend line, all right? But these all happen to be alkanes. So in that case, the higher boiling point has more carbons. All right, so methane would be 1 carbon, propane would be 3, hexane would be 6, and octane would be 8. So the highest boiling point would be octane, D. So that only works if they're all alkanes. 4, what is the name of this functional group? So you have a few questions where you're identifying functional groups. So here, this is a carbon double bonded to an oxygen with a hydrogen at the end. So this is a ketone. All right, 5, we got lots more naming. All right, so first step is to figure out which functional group we're working with. I see a double bond here, so that means we're working with an alkene, and that it's going to have the ending ENE. All right, next step is to find that longest chain. So I see this. We're going to count it. We want to make the functional group the star of the show, so it's highlighted in blue. So let's see here. 1, 2, 3, 4, 5 versus 1, 2, 3, 4, 5. All right, so if I go forward, it puts that bond at 3 to 4 versus backwards puts the bond at 2 to 3. So we're going to want to go backwards since 2 to 3 is lower. All right. So now I'm going to start putting pen to paper, ENE, pent, because there's 5 in the main chain. I got to tell you where this functional group is. With the double or the triple bonds, we go with the lowest of the 2 numbers. So this is at carbon 2. All right, and if it was just what was highlighted, that would be my name, but we have a branch here, a methyl branch. All right, so it's coming off of carbon 3, so we have 3 methyl, 2 pentene. All right, number 6 is another naming. So again, first step is to figure out our functional group. I see a nitrogen without a double bond, so that's an amine with an N. All right, it means our suffix is an-amine. All right, my next step is to find this longest chain. So I see this. All right, so I'm going to count 1, 2, 3, 4, 5. All right, so an-amine, pent, because there's 5. And then I have to tell you where this functional group is. It is at carbon 2, and there are no branches. So this is just 2 pent and amine. Feel free, any questions? All right, I'm going to keep moving. All right, 7. I just rewrote it here because I wrote the O and H looked a little funny. All right, so first step, identify the functional group. All right, so here I see a C double bonded to an O to an OH. So this is a carboxylic acid. And its suffix is enoic acid. Next step, identify the main chain here. Carboxylic acids are one of them that are always at carbon 1. So I'm going to start this as my carbon 1, 2, 3, 4. So I have enoic acid as my suffix, bute as the parent chain because there's 4. The next step is to tell the address, but this is one of them that always falls at carbon 1. So we don't need to say the address, but we do need to take care of this branch here. So this is a 1 carbon branch, so a methyl branch, and it's coming off of carbon 2. So 2-methyl butanoic acid. All right, 8 here, same steps. We want to identify that functional group. I see a C double bonded to an O at the end of the chain. I see that with that H here. So this is an aldehyde. It has the ending ANAL. All right. My next step is to identify that longest carbon chain. I see that here. Aldehydes are one of the 3 that always have to be at carbon 1. So I'm going to put this as carbon 1 and then count 2, 3, 4, 5, 6. All right, so I'm going to put pen to paper, ANAL, 6 carbons in the main chain, so that's hex. And there are no branches. These are just hydrogens that have been written out. No other carbons coming off as a branch. All right, so this is just hexanal. All right, number 9 and 10 is where we would want to use that trend line. So 10, they just give us the functional groups. 9, they give us names and we have to decipher which functional group they are. All right. So ANOL, anol is an alcohol. Ether, we didn't name these ones, but it's really simple. If it ends in either, it's an ether. Ane is alkane. ENE is alkene. All right, so now we're comparing a alcohol with an ether, alkane, and alkene. So we're looking for the most soluble, or I should have probably wrote this as most soluble. All right, the most soluble is going to be alcohol on that trend line. All right. Ten, we already have those. Now we're looking for the lowest. So lowest would be out of this list an alkane from that trend line. $11, we're naming again. So we're just following those steps. I see a nitrogen without a double bonded carbon. So this is an amine. And the suffix is going to be an amine. All right. And then I see next step, longest chain. And numbering it. It's right in the middle, so it doesn't matter if we go forward or backwards. But we'll just go forward because why would we make it more complicated if we don't need to? All right. Then we're going to end with an amine pent because there's 5. Next step is to tell the audience where it is. It's coming off of carbon 3. And the last step would be to take care of any branches, but there are no branches. So this is just 3 pent and amine. All right. 12, we technically I haven't mentioned it. So we have 2 competing functional groups here. We have a carboxylic acid and an amine. Okay, here's our carboxylic acid. Here's our amine. So which one do we choose? All right, which one becomes our suffix? When we have two competing functional groups, we go back to that trend line. All right, so carboxylic acids are the farthest on that trend line. Then it's alcohols, and then here's amines and amides. All right, so carboxylic acid is farther. He's the winner. He's going to be the functional group that we name after. This other functional group becomes a branch, and an amine branch is called an amino. I should spell this better. AMINO. All right, so we're going to name as if this was the only functional group. All right, so I figured out my functional groups. It's going to end in enoic acid. All right, now I need to figure out my longest carbon chain. So here we go. We got 1, 2, 3, 4. So it's going to end in enoic acid. 4 in the main chain, so bute. Next step would be to tell the audience where that functional group is, but this is one of the three that it's always at carbon 1, so we're good here. We can jump right into our branch, right? So no carbon branches, just this branch here, all right? So it's coming off of carbon 3, so 3 amino, no space. Let me make this closer. Butanoic acid. Any questions? All right. 13, we haven't seen this one yet. This is a nitrogen, but that same nitrogen is attached to a carbon that is double bonded to an oxygen. So this is an amide with a D. All right, and so this is going to be an anamide suffix. So I figure out my functional group and my suffix. I'm going to count carbons in my main chain. So it's carboxylic acids, aldehydes, and amides that are the three that always start at carbon 1 no matter what. So I'm going to go ahead and put that at carbon 1 and then count 1, 2, 3, 4. So putting pen to paper, I have an amide and then bute because there is 4. And then the last step would be branches, but there's no branches. All right, 14. We did this a couple times, but just as a reminder, when you have a benzene ring, so this part is the benzene ring. Benzene rings are 6 carbon rings with a double bond every other bond. Okay? There has to be this alternating double bond. All right? When you have that benzene ring attached to a carboxylic acid, so there's my carboxylic acid. I'm going to just label carb. The whole thing is called a benzenoic, oops, I forgot an A, benzenoic acid. All right, so that whole thing is called benzenoic acid. I don't have to do any finding of the parent chain or anything. That's the whole thing. What I do need to know is number this though. So where the carboxylic acid meets carbon 1 or meets the ring, that's always carbon 1. All right. Then it's up to me to decide to go clockwise or counterclockwise. I want to put the branches in the next lowest position. So I'm going to go clockwise. So that way this Br branch is at 2 and this methyl branch is at 3. All right. So benzoic acid. Oh, there isn't. Sorry. When I say it out loud now, I know it. Benzoic acid. All right. So that covers all of what's in blue. Now I need to take care of these branches. So I have a Br branch, which is just a bromo. So I have a bromo branch at 2 and then a methyl branch at 3. All right, I always list the alphabetical one first. So I'm going to list the 2-bromo first. So 2-bromo, 3-methyl benzoic acid. All right. 15, what is an example of a saturated compound? All right, so saturated, the only type of compound that's saturated is alkanes. Alkenes and alkynes are considered unsaturated. So we're looking for an alkane, which remember ends in A-N-E. So this one ends in A-N-E, so this is an alkane. E-N-E is an alkene. E-N-E again is an alkene. Y-N-E is an alkyne. So our saturated would be the pentane. (16) refers to our sorry. Well, you don't sorry, never mind. Okay. 16 refers to our last lecture, module 7, the biochemistry lecture. All right. So tertiary structure of the protein is maintained by which? All right. So tertiary structure is all about the R groups and creating 3D shape, making it globular. And it lists those 4 weird bonds that we talked about: hydrogen bonds, hydrophobic interactions, disulfide bonds, and ionic bonds. This is tertiary. Okay. The other answer choices here, A, this would actually be primary. So if the question asked for primary, the linear sequence between peptide bonds is primary. B, hydrogen bonds that create alpha and beta sheets. This would describe secondary. I can't spell. Secondary. And D would describe quaternary. All right. 17, true or false. Again, this is going back to our module 7. Lock and key theory is when a protein changes shape to accommodate that substrate. This is false. Lock and key, like it sounds, it's rigid. All right. This one is an exact fit. The description here is defining the induced fit model. All right. 18, true or false, enzymes increase the activation energy required to perform a reaction. This is also false. They decrease the activation energy. (19), this is technically module 4, but I grouped it at the end of module 7. So we saw this on Thursday's lecture. So this is the Le Chatelier's principle. So you have your little explanation on the reference sheet. All right, what to do when you have an, up or down arrow. So according to Le Chatelier's principle, predict the equilibrium shift. So if the concentration of HF was increased, all right. So when you have an increase arrow, you want to push away from where that increase is. Oops. All right. So in this case, to push away from where the left side, I'm going to go to the right side. All right. So this pushes in the forward direction. All right. If I'm pushing forward, I'm making more of this product and less of the reactant. So the concentration of this guy here would decrease. So that is what? B? Yeah. All right. 20. This looks a little funky. There's a reason I put this example on here. All right. So this is a triple bond right here. All right. So this is an alkyne. It's going to end in YNE. My next step to find that longest carbon chain, I see this. All right, here's where this one usually throws people for a loop. So to number it, all right, so you have a carbon here, so that we're going to call this carbon 1. You also have a carbon here, even though they didn't give us a point. They're implying that carbon because they only drew the triple bond from, at a certain point. So they're implying that there's a carbon 2 here, a carbon 3 here. Here's carbon 4, 5, and then 6. All right. So next step would be to put pen to paper, YNE, hex, because there's 6. And then we have to tell the audience where this triple bond is. It spans from 2 to 3, but we're only going to say the lower of the two numbers, so 2. And there is no branches. So 2-hexene, YNE, is our final answer. This kind of looks like it. 3, 2. All right, here we have to identify trans to butene. All right, so cis and trans. Cis is going to be on the same side, trans is going to be on the opposite side. And we're talking about the opposite side of that double bond. So if we draw an axis through our double bonds, this is what I see. All right, so we still do everything else the same. All right, we still are identifying that functional group. Cis and trans functional groups are always going to be alkenes, so it's that double bond there. And we're still figuring out our longest carbon chain. So the one on the left here, I see this is my longest carbon chain. The one on the right, same thing. All right. All right, so we're looking for those heaviest groups to be on the same or opposite side, okay? So it looks like they're both 4 carbons. They're both 2-butene. All right, this one's got an extra carbon. So heaviest group. So if we compare if we compare across the axis here, a hydrogen and then 3 hydrogens and a carbon, obviously 3 more of something plus a carbon is going to weigh more. So this is our heaviest group here. Again, we're comparing across this axis, hydrogen versus 3 hydrogens and a carbon. This is going to weigh more. All right, so we have our heaviest groups across the axis here. So this is definitely trans. All right, here, when we compare, again, this is going to be our heaviest group. This one, they're equal. So this one actually would not qualify as being a cis or a trans because they're equal. And you wouldn't need the cis or trans. So that leaves this guy with being the trans to butene. All right, 22. This was something I left drawn from the last session. All right, name the following molecules. So we have to first find that functional group. I see a nitrogen, but I see that same nitrogen connected to a carbon, double bonded to an oxygen. So this is an amide with a D, and the suffix is going to be an amide. All right. And then next step is to find that longest carbon chain. This is my carbon 1. All right, so I can't go to the right because then that's not a carbon. All right, so I can't make that carbon chain. So I have to go to the left here. This would be my longest carbon chain. 1, 2, 3, 4, which makes all this a branch. All right, so the gibberish I had from earlier here. So when it is a branch right off of that carbon, it is called, or I'm sorry, off of the nitrogen, it is not called a benzyl. What was I doing? It's called a phenyl. When you add a carbon to it, it's a benzyl. All right. So going back to naming this guy, all right. Pen to paper, our suffix an amide. 4 carbons in the main chain, bute. Now we just handle this as a branch. It's coming off of the N. So I say N, benzyl, bute, and amide. All right, 23. First step, identify that functional group. I see a nitrogen. It is not double bonded to a C double bonded to an O, so this is an amine with an N, and its suffix is an amine. All right, next step, identify that longest carbon chain. So I see 1, 2, 3, 4, 5, 6. Pen to paper and amine. 6 is hex. Next step, because this isn't one of those that's always at carbon 1. In this example, it just so happens to be at carbon 1. So we're going to put this, we're going to tell the audience where it is. So it's at carbon 1. All right, 24, you won't actually have to draw. You'll be choosing from, A, B, C, or D with different models. I just had drawing on here. All right, so this example is actually the same example from our Friday night lab. All right, so prop and amide. So amide, I'm looking for a C double bonded to an O, that same C bonded to a nitrogen. All right, prop, sorry, ours was pent, wasn't it? Okay, well, prop is 3. So now this is my carbon 1, so now I need to do carbon 2, carbon 3. Oh. All right, so there's my backbone, and then I have a dimethyl. This is not our example from lab. I apologize. It just looks really similar. So now I need to have NN, so I need to have 2 methyl groups coming off the N. So I need to have a CH3 here, CH3 here. And I guess I could fill in the H's here. This is what this would look like. $25. We got a weird looking structure again. All right. First step, to identify that functional group, I see a triple bond right here. So this is an alkyne, YNE. Next step is to identify that longest chain. For some reason, they decided to give us some 90-degree angles, but we can still work it out. All right. So numbering, I can number 1, 2, 3, 4, 5, 6, 7. Or I can do 1, 2, 3, 4, 5, 6, 7. So going backwards puts this double bond at 3 to 4 versus 4 to 5. So I need to go backwards. Okay. All right. So pen to paper, we got YNE, hept, because there's 7 carbons in that main chain. Now this doubles bond span or triple bond spans from 3 to 4, but I just say the lowest, so 3. All right, and if there's no branches, this is where I would stop, but I have this methyl branch coming off of 2, so I'll say 2 methyl, 3 heptyne. All right, any questions? All right, 26. Just again, make sure you have somewhere probably on your reference sheet the difference between an ester and an ether. So an ester has that C double bonded to an O, same carbon bonded to another oxygen, and it's in the middle. Here we have an ether is just an oxygen, no double bonds in the middle. All right. Again, you don't need to know how to name them, just kind of identifying them and knowing where they are on the functional group. And again, if you see either at the end of the name, then it's the functional group either. Usually it's kind of straightforward, so I don't really explain it. This again was just left over from the other group. I think I was just writing out the different functional groups for them. But that is the last question. So any questions from you guys?
I would like to ask if you can go to the first couple as I missed 1 through 4.
Sure. You just want to see that answers?
Yes.
Okay. Here's 1 through 3.
Can you tell me what the two say right after 5?
Trimethyl.
Trimethyl.
Because there's a methyl here,
Yeah.
here, and here. So it's tri instead of di.
Okay. Okay, I'm done with 1 through 4. I mean 1 through 3.
There's 4. Wait, I did this wrong. This isn't a ketone. This is an aldehyde. Good thing you
Well,
asked.
I'm glad I asked for us to go backwards, huh?
Ketone would have been C double bond to an O in the middle of the chain. So there would be carbons flanking that middle carbon.
Yeah, I asked that question, y'all.
Yeah.
Thank you. And
Yeah, no problem.
can I see you after everybody gets off, if
Sure.
you don't mind?
Any other questions from anybody else?
If y'all trying to ask a question, it's popping up that question to see if you have to be unmute. You got to press yes in order for you to accept it because she's recording it, I'm guessing.
All right, have a good night. Lorelai, you guys have your hands raised. You can ask a question.
I think it's one of them things where it pop up and you can't answer it.
Bye, Brittany. Lorelai and Ebony, do you guys have any questions? If not, you're free to log off. Yes, it's in the study guide is in last Sunday's announcement. Good night.
Well, my question was